Assalamu alaikum. Today we will complete our studying for chemistry IAL unit 2 Excel. We are studying organic chemistry, some reactions of alcohols. Okay, we will complete in this video reactions of alcohol with dehydration of alcohol. Dehydration of alcohol, it's a type of reactions which gives two products. One of the products will be organic compound, which is alkene, and the other product, it's inorganic, it's water. Why? Because from alcohol we will remove hydroxyl group and hydrogen atom. Okay, and we need to recall the rules of elimination of halogenoalkane. Okay, it works here. Recall these rules. Reaction condition: heating and concentrated phosphoric acid used in this reaction. Now let's see this reaction. In this reaction, alcohol hydroxyl group were removed when one of the neighbors hydrogen to produce alkene and water. Here I want from you to note something. If the compound is not identical, it's the same rules as halogenoalkane, we can remove the hydrogen atom from this side or hydrogen atom from this side. If we remove the hydrogen from the first carbon, we will form this butene, whereas the double bond between first and second carbon. While if we remove the hydrogen on the other side from the third hydrogen carbon, if we count from this side, we will get this compound, whereas the double bond is between the second and the third carbon. It's 2-butene. Here we have Z and E isomers. Okay, so we can get three products: 1, 2, and 3. We have three products here. Remember the elimination rules from halogenoalkane. By the end of this reaction, the acid will not be concentrated. Why? Because amount of water which will produce here, it will works to form dilute phosphoric acid. Okay, so by the end of reaction, we don't have concentrated phosphoric acid, it will be dilute. This is one of the notes for unit 3. Now, other common reaction for alcohols, it's oxidation of alcohols. In oxidation required to call the definition. There is more oxygen atoms, less hydrogen atoms. Okay, the product of oxidation. So when we say in the compound oxidized, we will find there is more oxygen atoms in the compound, or at least less hydrogen atoms. Okay, now product of oxidation in alcohols depend on the type of alcohol. We know we have three types of alcohol: primary, secondary, and tertiary. Okay, the type of product or the product depend on the type of alcohol. First, alcohol with the primary alcohol, when it's oxidized, it will form aldehyde. Let's see what happened here. Why it's oxidation first? Because here we have three hydrogens in this alcohol, which is primary. After oxidation, we have one hydrogen in this part, so it is oxidation. It's oxidation according to the definition. Okay, now secondary alcohol, when it's oxidized, and recall how we know the secondary alcohol. Okay, hydroxyl group bonded to carbon, which is bonded to one hydrogen, while here hydroxyl group bonded to carbon, which is bonded to two hydrogens. Now what happened here? It's oxidation, gives ketone. Again, we have 2 hydrogens in the same carbon. After reaction, there is no hydrogen. That means it's oxidation again, according to the definition. Now, tertiary alcohol will not oxidize. Now, what about oxidizing agent? Our main oxidizing agent in this syllabus, okay, it's our main oxidizing agent, yes, in this syllabus, it's potassium dichromate, potassium dichromate K2Cr2O7, and it should be in dilute sulfuric acid. It should be in dilute sulfuric acid. And when potassium dichromate act as a reducing agent, as oxidizing agent, sorry, when potassium dichromate act as oxidizing agent and reduced, its color will change from orange or yellow, okay, in our syllabus they mention orange, from orange to green, okay, from orange to green. That means an oxidation done and potassium dichromate reduced and the other substance oxidized. We can use the color change here to distinguish between types of alcohols, because primary alcohol will oxidize, secondary alcohol will oxidize. So color of potassium dichromate will change with potassium, with primary alcohol and with secondary alcohol. It will change from orange to green, while with tertiary alcohol there is no oxidation. It will not change, its color will not change, stay green, stay orange, okay. So we can use this color change to distinguish tertiary alcohol. There is no color change if alcohol is tertiary. Now some practical notes which is related, color change here, it's required in unit 2 and unit 3 in the same time, okay. Now practical notes: aldehyde, which is formed here, aldehyde which is formed in this oxidation, okay, oxidation of primary alcohol, it's very easy to oxidize. It's easier to oxidize than alcohol and gives carboxylic acid. Look here what happened. Number of oxygen atoms increase. If we compare between aldehyde, here we have one oxygen and one hydrogen, while here we have two oxygens and one hydrogen. So it's oxidation, there is more oxygen, okay. So the aldehyde, it's easier to oxidize than alcohol, and it's oxidized to give carboxylic acid. Primary alcohol, number of hydrogen atoms decrease, so it's oxidation to give aldehyde. Aldehyde oxidized, number of oxygen increase to give carboxylic acid. But we face a big problem to let this reaction go smoothly. What's the problem? There is a drop in the boiling point will occur between alcohol to aldehyde, then to go to carboxylic acid, okay. So we need to use a special way to can force aldehyde to oxidize to be carboxylic acid. What's the problem first? If we remember the intermolecular forces, here in hydrogen, what we have, hydrogen bonding between molecules. In aldehyde it's only polar, and in carboxylic again we have hydrogen bonding. In carboxylic acid we have hydrogen bonding. What happened here? High boiling point due to the hydrogen bonding, then a drop in the boiling point, after that increase in the boiling point. Let's stop here. This reaction needs heating, okay. This reaction need heating. So if the reaction occurs in a beaker or in regular system, what will happen? When aldehyde form, it will evaporate and escape from the reaction container and reaction mixture. So we need to solve this problem. Let's see how we can solve this problem. To stop, first let's say we need to stop here and collect aldehyde. If the reaction occurs in regular beaker, what will happen? While we heating the reaction mixture to can oxidize the alcohol, when aldehyde form, it will evaporate. It will evaporate and will not react, and we can't collect it. So what will happen? We will use this method. What we have in this method, alcohol added slowly from here, and the oxidizing mixture in the flask, okay, oxidizing mixture, that means potassium dichromate and sulfuric acid. Now what will happen with heating? When alcohol added and oxidized, aldehyde form and will evaporate. It will evaporate and condense here okay, and collected as aldehyde in this part, collected as aldehyde in this part, okay. So it will not, we will not lose the aldehyde because it will collected by simple distillation, okay. So with heating, when we add alcohol, it will oxidize, gives aldehyde. The boiling point of aldehyde is very low, so it will evaporate, but it will not escape because the system is not open. It will go to the condenser here, it will condense and collected here. Later we will know, this is not the suitable way to oxidize the to collect the organic products, but now it's a simple idea. We need to explain how we will avoid escaping of aldehyde, okay. So by slow adding of alcohol and distillation of aldehyde, we can collect the carboxylic aldehyde and prevent its escape. Now, to complete the reaction to carboxylic acid, we need to follow another or different procedure, okay. What we will do to prevent evaporation of aldehyde, we will use heating with reflux. Heating with reflux, here we will have fractionating column. This fractionating column will allow the substance, when we add the alcohol, it will oxidize, then aldehyde will evaporate, okay. When it evaporates, it will condense again here and return to the reaction mixture, okay. So fractionating column will prevent escaping of aldehyde. It will form and will evaporate as happened in the previous example, but when it goes up, it will condense here, okay, and return back to reaction mixture and will oxidize. Remember, oxidation of aldehyde, it's easier than oxidation of alcohol. So when it return back here with this vigorous condition, which is here, but with this heating, it will oxidize again. So to prevent evaporation of aldehyde, we can oxidize it. To give carboxylic acid, we use reflux heating with this fractionating column called reflux, okay. When aldehyde form, it will not escape from reaction mixture and to return back to the flask to oxidize and give carboxylic acid, okay. By the end of reaction, we will have a mixture of chemicals which take us to our next topic. Now here we have mixture of product, some alcohols which not oxidized, some aldehydes which not oxidized, the oxidizing agent, different chemicals. This will take us to the next topic, which is purification of anorganic liquids. This will be our next topic, inshallah. Assalamu alaikum.